Hi everyone, in this video I'm going to review a concept with you that you likely learned when you took geometry. And it's the idea of finding the sine, cosine, and tangent of an angle if that angle is part of a right triangle. So this is a right triangle. It means one of the angles is 90 degrees. And the key here is that, first of all, we have a right triangle and theta is an acute angle, meaning it's less than 90. degrees. So theta will always be less than 90 degrees if we're dealing with a triangle, a right triangle, because if I have one right angle, the other two are smaller. Okay, so now let's define these functions, sine of theta, cosine of theta, and tangent of theta in the given triangle. The SOH part, S-O-H, is supposed to remind me that sine is a ratio of side lengths. The side lengths that I'm comparing are the side opposite of my angle and the hypotenuse of the triangle. So if my angle is theta, so actually let's write that down first. This is telling us that sine of theta equals the opposite, that's what the O stands for, over the hypotenuse, that's what the H stands for. So if my angle's theta, the opposite side length is the one that is the side that doesn't border theta, that doesn't border the angle. So we walk across, that's going to be the opposite. So to find sine of theta, I do opposite, which is B, over hypotenuse. This is the hypotenuse, so that's C. So sine of theta is B divided by C, just a ratio in this case. Cosine of theta, we remember how we get this as a ratio of side lengths by using the same play on words, Cah. C-A-H now is supposed to remind us that we find cosine of theta by taking the adjacent side, A, adjacent over the hypotenuse. So the adjacent side to theta is going to be this, is going to have length A, because it's the side that touches theta, but the one that's not the hypotenuse. So C is the hypotenuse because it's across from the right angle. So the adjacent side is the one which is not the hypotenuse, but still touches theta, and the hypotenuse is C. So cosine of theta is the ratio A divided by C. Tangent of theta, I remember by using the TOA. So the O always stands for opposite, the A always stands for adjacent, so I remember that tan of theta is the ratio opposite, O, over adjacent, A, TOA. So if I go to theta, like we saw before, the opposite is B, and the adjacent is A. So you may have seen these ratios before, sine, cosine, and tangent, but we have some new ones that I want to teach you about. Cosecant is just the flip of sine. So cosecant is the same as 1 over sine of theta, the reciprocal. So if I try to do 1 divided by b over c, well, in order to divide by a fraction, I multiply by its reciprocal, so it's going to be 1 times c over b. So cosecant of theta is just c over b. So in order to get the cosecant, I can get the sine and flip the ratio upside down. And that gives me my new ratio, c over b. So another way you could think about this one is just the hypotenuse divided by the opposite. So I flip sine upside down. Secant, you might expect, is the flip of cosine. So secant is going to be c over a. And cotangent is the flip of tangent, so that's going to be a over b. So one way that I like to remember this is sine gets paired with a cosecant, so I add a c, but cosine already has the co, and so I get rid of it. That gets paired with secant. Tan doesn't have a co, so it gets paired with cotan. Okay, so let's do some examples where we're actually computing these trig functions for a couple angles theta. So here's my first picture. I have a well-labeled right triangle, so I'm in the situation in which I can use these definitions. So remember, sine of theta is going to be the opposite over the hypotenuse. So if I go to theta, the opposite one is the one that doesn't share a side with theta. So that's going to be 12 over 15. And I can easily do the cosecant now, because cosecant is just the flip of sine. So that's 15 over 12. Now, cosine of theta is the adjacent over the hypotenuse. So in this picture, the adjacent length is 5. This is the adjacent length, so that's 5. And the hypotenuse is 15. And I can easily do secant theta because that will just be the flip of cosine. So that's 15 over 5. And finally, tangent, the TOA part is opposite over adjacent. So opposite we saw was 12. And adjacent is 5. So I get 12 over 5 for the tangent. Cotangent is just the flip. So 5 over 12. So it's pretty easy once you can identify which is opposite the angle, which is adjacent to the angle, and which is the hypotenuse. Then I'm just forming these ratios, and I remember SOA, CAH, and TOA. So now let's do a slightly trickier example. I want to find sine, cosine, tangent, cosecant, secant, and cotangent of the angle theta when all I know is that sine of theta is 4 over 5. So my first step when I have this information is to draw a triangle, a right triangle, that satisfies that. So draw a right triangle with the information given. So here's my right triangle. Maybe this is the theta that I'm interested in. And if sine is 4 over 5, that means the opposite of theta is 4, and the hypotenuse of theta is 5. So I can now, step 2, label my triangle. So the opposite should be 4, and the hypotenuse should be 5. The next thing I need to do is find this third side. And I can do that in 2 different ways. In this particular triangle, I might recognize that it's a special right triangle, the 3, 4, 5 triangle. So I know off the bat that that one's got to be 3. If I didn't recognize that, I would use Pythagorean theorem. So if I want to know this length, then because it's a right triangle, x squared plus 4 squared equals 5 squared, and I'll solve for x. So this tells me x squared plus 16 equals 25. That tells me that x squared equals 25 minus 16, which is 9, which tells me that x equals plus or minus 3, but since I'm looking for a side length, I can just take the plus, so x equals 3. Now I have a fully labeled triangle just like before, and so it should be easy to find the sine of theta. Well, that one I already knew. Sine of theta is 4 over 5. The cosine of theta is going to be the adjacent, so that's this one, adjacent to theta, over the hypotenuse. So that's 3 over 5. The tangent of theta. So here we used opposite over hypotenuse. Here we used adjacent over hypotenuse. Here we're going to use opposite over adjacent. So opposite is 4 and adjacent is 3. So I've got 3 of them. Now I get the reciprocals by just flipping these upside down. So sine is paired with cosecant, and that's going to be 5 over 4. Cosine already has the co, so it's paired with secant rather than cosecant. and I flip it upside down, so I get 5 over 3. Tangent doesn't have a co, so it gets paired with the cotangent. And I flip 4 over 3 upside down to get 3 over 4. So that's pretty much all there is to it with these trig functions. When we're given an angle theta that's acute, and we can draw a right triangle. In the cases where we can't draw a right triangle, like say we wanted to find sine of some obtuse angle, if that's my theta, then I can't use these strategies. So we need a new definition for sine, cosine, and tangent. And that's what we'll give in the next video.